Welcome to the SCIA and FRILO Integrated Structural Analysis webinar. My name is Manuel Lopez, and today we will explain a little bit more about this development. First, let me introduce the main speakers. As you know, Manuel Lopez, I am the account manager for the UK and Ireland for SCIA, but also for Nemetschek Engineering. Thank you so much to all the UK customers and Irish customers for joining us today. And our main speakers are Victoria Rowkowska. She's the responsible for international sales and partner management for FRILO DC, and she's based in Stuttgart. And also Manuel Walter, our product director for management of FRILO and DC, equally based in Stuttgart. Thank you both for attending today's webinar. Let me go through the agenda so I can show you what's coming in the following hour. As you know, the welcome, the introduction to Nemetschek Engineering, that will be done by our Victoria Rowkowska. She will explain you more about our group. Then we will have a live demonstration of the structural analysis workflow. This will be performed by our Manuel Walter, including the model calculation in SCIA, selection of a column plus loads transferred to the foundation, and also the foundation export for the extended detailing in FRILO FD+. After that, then our speakers will explain the other interfaces between SCIA and FRILO. And finally, we will have a Q&A session. So please, I really invite you to type in the chat all your questions. We are more than happy to answer. With all this being said, I send the microphones to Germany, where Victoria can introduce. Thank you.
Thank you very much, Manuel. And before I start with the introduction of the Nemetschek Engineering brands, I would like one more time to welcome you to type your questions into the questions section in your GoToWebinar panel, and we will for sure get back to them after the end of the presentation. Or if there will be any questions left unanswered, we will get back to you after the event so that each question gets its answer. And the introduction of the Nemetschek Engineering means the introduction of 3 brands that are building up this Nemetschek Engineering business unit within the Nemetschek Group. The first brand is SCIA Engineer, SCIA and SCIA Engineer in particular. And SCIA is a structural analysis and design solution for all types of structures, especially complex structures and geometries, can be modeled in detail, and you can clearly visualize your model structure in this tool. It has a wide range of functions and is suitable for the design of office buildings, industrial plants, bridges, stadiums, high-rise buildings, and to mention a few other structures as well. So it's very flexible solution. The supported materials are reinforced concrete, prestressed concrete, steel, aluminium, and timber. And of course, you can combine several materials in one model. All Euro codes are implemented, and the national annexes, like the differences for each specific country, are also available. The next solution that is forming the Nemetschek Engineering business unit is FRILO, and FRILO is providing a wide portfolio of detailing solutions. So these are individual programs for single component analysis and design, and it is particularly suitable for typical simple structures, for example, single and multi-family residential houses or common industrial plants. You can also design the precast elements with FRILO applications, and you get your results much faster because, like in the 3D modeling, it's rather time-consuming. FRILO component-oriented calculation approach significantly reduces the modeling effort and enables a particularly simple, fast, and precise verification. Portfolio consists of numerous detailing programs. These are around 150 for today, and these are, for instance, individual solutions for reinforced concrete column, slab, wall, crane runway girder, dovetail connections, crack width verification, punch and shear analysis, and so on and so forth. FRILO is particularly broadly positioned in timber construction and also enables the design of aspiring building materials such as carbon concrete, for instance. And last but not least, the products from various component manufacturers are integrated into FRILO solutions, so that, for instance, in punch and shear analysis, you can use Isocorp, Combar, Carborefit, Filigrane, or RFA Tech punch and shear reinforcement, and already design your reinforcement in FRILO programs. And the last brand that is included into Nemetschek Engineering brand portfolio is DC Software. And this is, in fact, everything that geotechnical engineers' heart desires, so to speak, poetically maybe a little bit. And it comprises solutions from the foundation engineering part and soil mechanics part. Soil mechanics stands for laboratory and field testing of the soil. Foundation engineering programs support the efficient calculation of stability in the ground, as well as planning, design, and dimensioning of foundation structures, such as, for instance, dimensioning of excavation pits, foundations themselves, retaining walls, soil nailing, underpinnings, piles, and many more. Soil mechanics, in turn, provide the analysis of geotechnical parameters of the foundation soil, and in addition, you can display graphically and evaluate the results of the soil analysis. Okay, so what does it mean, like all three brands united and sharing one vision? First of all, it's important to mention that we have one joint management and one CEO in the person of Markus Gallenberger. And this means, in turn, that all three brands think strategically in the same direction, strive for the same goals, and work together on innovations. The interconnectivity, interoperability is in focus, of course. The teams in various departments are also work together across the locations and across the companies, these different brands, and in product management, marketing, sales, development, customer success. We have projects that are running across all of the organization of the Nemetschek Engineering. And now, before I hand over to Manuel Walter to show you the live demonstration of the workflow between SCIA Engineer and FRILO Foundations program, I would like to summarize the benefits of the Nemetschek Engineering approach within the Nemetschek Group. First of all, of course, this comprehensiveness. We are offering a comprehensive solution that has both tools for 3D and 2D member analysis, like the analysis and design of the complete building using the finite element method, and on the other side, the detailing, extended detailing with the granular results in the detailing individual solutions. The second benefit is seamless cooperation. It is the interconnectivity of the solutions themselves, and also the possibility to cooperate faster, smarter, avoiding some manual errors within all of these application environments. The solutions are developed and created by engineers that have experience in engineering, in structural engineering themselves. This is why they are very close to the needs of the users, and they can understand very well which features are required by our users, and then can develop very intuitive solutions that don't need long onboarding time. Integrated BIM workflows means that we are not only interconnected inside within the three brands, but we are open for outside, and we are able to exchange files with external solutions in IFC, in SAF file formats that are supported by most of the brands on the market, and we will work on continuous development in this direction as well. And the most important is the last benefit. In fact, our goal is to provide the high speed and high quality support for our customers within one team that will serve all of the three brands. Okay, so now I'm through with my part. Thank you very much. And I'm happy to hand over to Manuel Walter that will show you the live demonstration of the workflow between SCIA Engineer and FRILO Foundation program. You're welcome, Manuel.
So, hello everybody, warm welcome from my side as well. And thanks for the introduction to my pre-speakers. I would like to show you the workflow from moving some geometric and force informations out of foundation design from SCIA Engineer to our FRILO FD Plus module to calculate the foundations more in detail. Yeah. Okay, so I would like to start with a model, an existing model on SCIA side. Okay, so that's the model I set up for you. So let's say it's some kind of a water tank or of a container building. I can show you the volumes, for example, and the shadings as well. So now you can recognize it a bit better what the model, how the model is built like. So we do have 4 columns and 4 foundations. And I would like to show you later on how that foundations can be transferred into the FRILO world. And of course, we do have some beams on top of that columns, and we have a shell object representing the tank itself. And of course, the tank has a bottom and this is modeled as a plate element in the end. Let's have a short look on the load cases, the different load cases I have set up. Of course, we have the dead weight of all the components of the model that are calculated automatically, so we don't see the loads in detail right now. Then I've set up a second load case. It's a snow load case. Sorry for the German names, but that's just the load case names that are defined by me. So we have some snow loads distributed on top of that tank, for example. And then of course we have an infill, an water infill. So the load case assumes that the tank is full of water. The water level is on the very top, and therefore we have a circular force distribution at the bottom due to water pressure, and we have a linear water pressure starting from the top and having its maximum on the bottom of the tank. Yeah, and just to show you another load case, I added some wind loads on one side of the tank to make sure that we have a couple of live loads in the model available in the end to show a bit some specifics of the combination of the load case combination and stuff like that. Okay, so after that, when the model is defined well and all the loads are in place, I can start the calculation. And in the end, it doesn't matter whether it's a linear analysis or whether it's a nonlinear one. So in the end, we are transferring the loads that are calculated within SCIA Engineer. So to keep it simple, I would like to show the workflow just using a linear analysis. And once the analysis is done, the next step to figure out which foundation is the most dangerous one, which needs to be calculated in detail afterwards. I would like to have a look on the resultant forces in all these 4 foundations. Therefore, for example, I will choose the resultant function, and I use the reaction force. Okay, so now I type all the foundations. And I would like to show, for example, the resultant internal force, the vertical force, to localize the most important foundation. So I choose the type of loads. In that case, for example, I choose all the combinations, all the design combinations that are done internally automatically. And after refreshing the model, we can see the single loads, so the resultant forces in the foundations of each of these 4 foundations. So in the end, I would figure out that in that case, that foundation that I named FD1 is the most important one because the resultant force in vertical direction is the biggest one. And I would like to show the workflow to bring all these informations now to the FRILO design model according to that foundation that I named FD1. Okay, so next step, I will delete the results just to show you the way how to transfer it a bit better. And then we need to clarify which foundation I want to hand over. In that case, I can type in up here in the search field. For example, the function is called FRILO foundation input. So that's the first step because I need to name the foundation as a previous step. Otherwise, I can't export it to into the FRILO foundation module. So I can type in a name for that foundation, for example. And afterwards, I need to select the node. And by doing this, the foundation is named in the end, so I can see the user-defined name in the end. And that's a very important step, because without that name, you are not able to hand the foundation over into the FRILO world. So that's a necessary step that needs to be done first. After that, I can call the other FRILO function. It's called FRILO foundation check. So now we are going to hand over all the necessary data automatically into the FRILO world. First of all, the most important thing is to choose which loads and load cases you want to hand over, because the design, the foundation design depends, of course, on the loads or load cases you hand over. And therefore, it's first of all, it's very important to know whether the calculation is done on a linear base or on a non-linear base. Because if the calculation is done on a linear base, it's not necessary to hand over design combinations. So in that case, you might hand over just single load cases on a characteristic base, because in that case the combinations can be done on the foundation side itself. Because, for example, if the calculation is linear, so additional internal forces according to theory of second order are not taken into account. So if the calculation is done in a non-linear way, you should hand over the load combinations that are automatically or user-defined done by SCIA Engineer. Therefore, we need those additional internal forces according to theory of second order, for example, to take them into account in the foundation calculation afterwards. So that's the first step to be done, and I will show you both steps, and therefore I'm going to start by handing over, for example, single load cases. So if I type in load case, I have the choice to choose one of my 4 predefined load cases and hand over those characteristic internal forces in the single foundations. Yeah. To make it a bit more easier, I defined a load class up front, and within this load class, I just set up that all the load cases are available within one transfer file. That makes it much more easier. So in that case, if I start the export now, all the characteristic load cases are available for the foundation design in just one step. So I don't need to do that step 4 times to have all the single load cases transferred, for example. Okay, so after that is done, I choose the function export to FRILO Foundation FD+, and yeah, we will check the box up here. So it says select the FRILO Foundation data for single check, and now I can choose one of these foundations. And now you can see why it is important to name that foundations with the function FRILO Foundation, because you can just now choose that the text that you have set up, and not a node and not a foundation type that is modeled within SCIA Engineer. So after clicking on the FRILO name, on the foundation name, the export starts, and then another very important decision needs to be made, because there is a difference on how the loads are now transferred into the FRILO world. So first opportunity to hand it over is by clicking yes, means that not the resultant forces in the support are handed over, but the internal forces at the very at the bottom knot of the column are handed over. That's somehow important because we need some additional information about internal forces. So means that if we talk about handing over load combinations, we need to know the characteristic combinations and the design combinations both. And these informations are only available by handing over internal forces. If we hand over just the support forces, this information is not available. So in that case, we only have design values available, and that makes the calculation on FRILO side a bit more complicated. So that's why if you type yes, the internal forces are handed over, the internal column forces, and if you type no, the support forces are handed over. So what's the difference? The difference is only important if we have additional loads besides that support node. For example, if we have a load that is directly acting within that node at the very bottom of the column, or if we have a load which is localized on the foundation itself, because in that case, that load doesn't affect the internal forces of the column, and therefore, if we would like to take these additional loads on the node or on the foundation into account in foundation design, we need to hand over those support forces, because only in the support forces additional loads are included. So that's the difference. As long as there are no additional loads available, I would suggest always to use the function yes and to hand over internal forces, like in the model here. Okay, so in that case, I type yes, and then automatically in the background, the FRILO Foundation module starts. I will show you the result in a couple of seconds. Now we are done. And that's the model which is handed over from SCIA Engineer to FRILO Foundation module automatically. So we can see all the geometry is predefined according to the values that I have chosen in the SCIA Engineer model. And of course, all the load cases that I choose to hand over are available right now. So I will show the load case table. In that case, I think I handed over the single load cases, and what we can see that we have now 8 different loads available, and in the end the combination of these loads, of these single loads to get design combinations, is done within the FRILO module itself. That's the first way how we can go from SCIA Engineer to FD Plus by using that link. Now, let me show you the other way as well. So in that case, just imagine the calculation on SCIA Engineer side was done in a non-linear way. So we would like to take theory of second order into account. And in that case, I would choose that I would like to hand over combinations. And for example, the ultimate limit state combination on a design level. So means including partial factors of safety bigger than 1, for example. Then I choose, for example, another foundation. So I take the FD2 now to hand it over. And in the end, the same process is going to be started. It's going to be started, and the foundation module will open in the background. Once again, we need to make a choice whether we would like to have internal forces or support forces. In that case, I will show you the other way. So I choose the support forces. And of course, in the end, we will end up in a big amount of combinations that are handed over, as you can imagine. So by defining 4 different load cases, we will have a lot of possible load case combinations, and all of them are handed over, of course. So we don't sort them as some of them out or stuff like that. So we hand it over all the single combinations into the FRILO module. That needs a bit of time due to the amount of available combinations right now, because the calculation in the FRILO module is done automatically in the background. So it's in case you change anything, the foundation is recalculated in the background automatically, and that's why it takes some time according to the amount of load cases and combinations, for example. Now we can see all these combinations that are handed over, and I would like to say something about the details in those combinations. So as we can see, we have a index D, means that we are talking about design values, of course. And if we had a nonlinear calculation, we can see that by regarding the single components of the internal forces. For example, if we see we have a moment around the x-axis according to theory of first order, that's the first column, and we have the same moment according to theory of second order. In that case, the values are the same, and that means that we don't take a theory of second order or nonlinear calculation into account. So once a nonlinear calculation is done on SCIA Engineer side, you will see that there is a difference between those 2 values, and that's the sign for you that in the foundation calculation you can take these additional internal forces according to a nonlinear calculation into account. You might you might choose not to do so. So it's a setting you can choose for each check that is done internally, whether you would like to do it regarding those additional forces according to theory of second order or not. So that's the point that can be chosen for each geotechnical check, for example, within the foundation design. Okay, so, but let me open a more simple more simple project. So that's the previous foundation, the previous export. In that case, we just handed over characteristic load cases. So as you might remember, we had a wind load case in Y direction. We had, of course, the dead weight load case of the model of the water tank itself. I set it up a snow load case and a water load case. And as you can see now, we are talking about characteristic values. You can recognize it at the index K right here, or you can also recognize it within the basic parameters. There you can choose whether you would like to handle with characteristic values or with design values. Of course, I've set it up the standard according to the National Annex of Great Britain. That's why British Standard EN 1992 is chosen. And of course, that's the standard for concrete design. And according to that, the geotechnical British National Annex of EN 1997 is predefined automatically as well. Of course, after the calculation, we have some detailed information about the checks that are done internally. So as I told you, we are calculating all the checks automatically in the background, and that's why you can see within that structure here already in the user interface whether the foundation fits or whether it doesn't fit. So what is shown is the utilization factor, and so far, so if we are below than 100%, the foundation fits and might be optimized somehow to get it to get the utilization factors a bit more near to 100%, for example. Yeah. So if it doesn't fit, you will recognize it immediately. For example, I could change one of the measures here, do a recalculation. And after that, I will show you, for example, what can be chosen. So which soil mechanic checks can be handled out. So for example, I change the method from a user-defined or simplified calculation method to a more accurate one. And in that case, I will show you the function where you can choose which check is done and on which base. Okay, so now the calculation is running. And I will change to the results right now. Now you can see the calculation results according to the choice I've done before. And of course, in the end, you can have a really detailed output file which shows all the calculations that are handed over, that are calculated internally. Of course, we see all the load cases once again, so they are listed, so we can compare them with the internal forces or the support forces on SCIA side. For example, these load cases are handed over. We can see we have 48 in that case. That's pretty much for such a simple foundation, I think. And yeah, in the end, we see an overview of the results. That's this table. And within that overview, we see all the utilization factors, for example, for each check. So we can simply prove whether the foundation fits for the geotechnical design in the first table. And we see the reinforcement that is necessary coming from the bending design, the shear force design, and the punching design. Yeah. So that's what we display, at least if we choose, for example, a short or a brief output file, and if we choose a detailed output file, all the information that is calculated, all the values that need to be taken into account in each check is printed out for a more detailed output file in the end. Okay, so one last thing I would like to show you, for example. So we are talking about a single foundation, a isolated foundation in that case. It is also possible to calculate socket foundations, for example, or pad foundations, and therefore, of course, we have a load transfer and a model transfer to all of our other FRILO foundation modules. So let me name them. So we have a module called FDB+, that's a pad foundation. That means that's an internal socket in the foundation. Within the FD Plus module, we can also calculate foundations with the external socket. I can show you that by choosing the option that we'd like to model a pocket as well. So, and that could be an internal one or an external one as well. And so the next possibility is to calculate it as a massed foundation, means that's a foundation which is founded a bit deeper in the soil. So, and that it's calculated by having a equilibrium between active and passive earth pressure. For example, for masts or stuff like that. Then we could hand it over to a strip foundation, means that we would like to have a foundation strip. And in that case, we are talking about walls and not anymore about columns. So the column is going to be extended and modeled by a wall in the end. Then we have we do have a module to calculate reinforced raft foundations. So that's quite often if we are talking about foundations in inner city buildings. So just imagine you are nearby the border to the next house, and in that case we need to calculate a raft foundation that is loaded externally at the very edge of it. And the last possibility, for example, is to calculate the entire foundation as a elastic bedded beam instead of a rigid foundation. That's sometimes very important if we are talking about big foundations that have a low stiffness, for example. In that case, the better calculation model would be to have it as a elastic bedded beam. Well, so that's it from my side, showing the link between SCIA Engineer and the FRILO Foundation module, how to hand over the loads. So just to summarize a bit, always be aware of which type of calculation is done. So is it a linear one or a non-linear one? And according to that calculation, define which loads need to be transferred. So are we talking about characteristic loads? That is absolutely sufficient if we have a linear calculation to hand over characteristic loads. And in case of a nonlinear calculation of the 3D model, it's the better way to hand over the design combinations to have these nonlinear effects and these additional internal forces to take them into account. Well, and in the end, the calculation can be calculated in detail with the foundation module, and the results are all the geotechnical checks, of course, and the design of the reinforcement for bending, for shear forces, and for punching shear. Yes, and in the end, once all the checks are done, you can just print out the result list or the result document and add it somewhere into your entire calculation document, for example. All right, thank you very much for your attention. And so I might, if there are any questions, just use the dashboard, and I would try to answer some questions in the QA session afterwards. And if there are too many questions, we will answer them after the webinar, and we will reach out to you by email, of course. Okay, so now I hand back to Victoria.
Thank you very much, Manuel, for this deep into detail presentation of the workflow between SCIA Engineer and FRILO Foundation Program. And before we go or proceed to the questions questions and answers part, first, please, I would like to draw your attention to the section which is called Documents, I think, in English version, or Unterlagen in the German version of the GoToWebinar panel, because there we have prepared for you detailed workflow paper describing exactly this workflow that you have seen today in the live presentation of Manuel. And another information that I would like to share with you is what other interfaces or connections are available right now between the FRILO and SCIA solutions. And maybe, Manuel, you can give me back, yes, exactly, so that I can share my screen for a while. Okay. So I hope now you can see my screen.
Yes.
And what I wanted to mention is that apart from the SCIA Engineer and Foundations, FRILO Foundations interface, we already have available and delivered the masonry wall connector from SCIA Engineer directly to the masonry wall calculation solution of FRILO software. There is one more interface that is available already since certain time. This is the connection based on SAF file transfer between FRILO building model, which is called GEO. This is a load descending or load distribution program of FRILO software that allows you to distribute the characteristic loads in the entire building and assign them to the individual building components. But in case we have some situations where the floors or the stores are not placed exactly over each other, we need some extended earthquake analysis, then we do need to calculate such model in the 3D engineering solution, structural engineering solution. Then we are able to smoothly transfer the entire building model from FRILO to SCIA Engineer, so the other way around. Another interface that we are currently working on is the timber connections of FRILO. The program is called HO13, and it's offering a wide range of timber connections, as you can see on the visualization in the slide, and it will be available already in May in the next release. And we are planning, of course, the developments in the direction of the interfaces between FRILO, SCIA, and DC software for the next releases as well. And we would be very happy to find out what features or what interconnectivity is helpful in your projects, is helpful in your everyday work. So please feel free to share it with us in the final survey.